Moshi Moshi! Welcome to video number 2. Well, hopefully we get through the whole lesson on this video, but we'll try, okay? So now you can go ahead and try these problems here, okay, and see how they go. Use these notes, okay? Now let's move on to techniques to evaluate limits. Part 2. Dividing eye technique, I think you might already know, but it's actually kind of easy and kind of fun. But remember, before you try any limit techniques, number one thing to do is what? It's actually this. This is your BFF, right? You're going to plug in x equals 1 and see what happens. So I'm going to find the limit as x approaches 1, and I'm going to do this, right? So I'm going to go 1 cubed minus 1 over 1 minus 1. And what do you get? Ooh. And what happens when you get ooh, right? You got to use a different technique, right? That means it's indeterminable, not undefined, indeterminable, okay? So let's go ahead and try the dividing out technique. What does that mean? It kind of goes back to your Algebra 2 days when you used to rationalize, rationalize your fractions. Here's what I mean. You have to use simplification. So x cubed, oh, whoa! Yes, you know how my iPad does that sometimes, okay? X cubed. Oh, x cubed minus 1 is what exactly? It's x minus 1, right? When you factor it out, it's x squared plus x plus 1. That's the weird one, remember? That's the strange one where it's like a minus, but it's actually a plus plus. And then the bottom is x minus 1. Hi-ya! I see a little kung fu happening here. Hi-ya! Hi-ya! You got to simplify everything before you conclude. So I get this. I'm still trying to find a limit, but now I've crossed that out, and I get this remaining. And at this stage, I have to ask myself, can I simplify further? And I say no. That means I would just ds now. So when I ds, I get 1 squared plus 1 plus 1, which is equal to city. Now, go ahead and see if indeed the limit of this guy is 3 on your calculator using the calculus function. And I bet you will. Okay? So check it out. And you can also try graphing it too and using the table and see if that works as well. But that's how you do it. It's pretty easy. Okay? So again, you have to simplify everything first. So before you see me do this guy, how about using the dividing out technique? Do you see why this is dividing out technique? Because there's going to be always a kung fu. Hiya, hiya! All right? So you might want to try this one on your own. Okay? Of course, I'm going to always do my first method. ds, right? So I'm going to ds this, and I'm going to pretend like I wrote everything, and I'm going to plug in negative 3 squared plus negative 3. You know, I'm putting parentheses. Whoa, I didn't write that. I'm putting parentheses everywhere around the negative because I don't want my negatives to get messed up, okay? So minus 6. I have to keep the integrity of my negative, okay? And then I'm going to simplify everything, okay? Well, actually, you know what I'm going to do? I'm not going to be a lazy teacher. I'm going to write limit as x approaches negative 3. But we ds now, right? We ds now, we conclude. 9 minus 3 minus 6, that's 0. And that's going to be 0 over 0. Oh, sorry, 0 over 0. 0 over 0. Hi-ya! That's an indeterminable. So indeterminable. Indeterminable. So we'll go ahead and try the divide out technique here. I like the dividing out technique. Usually it works really well, okay? So you'll know when to use it. And you'll know when it's going to work out and when it's not going to work out. So don't worry. So limit as x approaches negative 3. And we're going to go factor. Let's how you factor. I remember how to factor this? It's been a while, I know. X, and you're like 3 and a 2. And it's going to be a positive here and a negative here. And then you get on the bottom x plus, oh, sorry about that. My pencil does that, or my, you know what, I think now I'm convinced it's my iPad. I don't want to mess with you here, so today is not a, okay, anyways, do you see what's happening? Okay, let's go with that. And then x plus 3 is on the bottom here. Hi-ya! All right, and then you have limit as x approaches negative 3. You have to keep writing the limit because you haven't done the limit operation yet. So make sure you write everything for me as you do the calculations. And you're left with x minus 2 here, and then you would ds here because you can't simplify anymore. So when you do, you get negative 5, and that is your final answer. Okay, if you doubt your answer, go ahead and check again. Okay, you can graph, use a table, you can use a calculator, whatever you need to do to check. Okay, all right, so that's called dividing out technique. Okay, All right, that's fun and easy. Let's go to the rationalizing technique. Dun, 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 dun. I think I was using the wrong word here. Rationalizing. I meant simplifying, okay? Sorry about that. Rationalizing. Dun, 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 dun. Now, what's nice is, you know how you used to know, the conjugate of a plus b is a minus b, right? Well, rationalizing, when you're rationalizing, a rational expression also has a conjugate. And it's the same logic as a conjugate of a plus b. So here's what I mean. So again, we're going to try, of course, we're doing the same thing. We're looking for the limit. First step is always to ds, man. Okay, we're going to ds. Limit as x approaches 0. I'm going to plug it in. Okay, so I'm going to plug it in, sorry. 0 plus 1 minus 1 is 0. And I get 0 over 0. Ooh, okay, so indeterminable again. So I put a big question mark for indeterminables, okay? So second method, you're like, I gotta use another method. And the next method that's easy for you, I guarantee you, the next easiest method is gonna be this method that we're doing right now, analytical method. Okay, graphing, you probably can't graph these functions on your own, like on Scratch. So you may want to always do analytical first after this method, okay? Let's try this. So we're going to go limit as x approaches 0. And look at the top here. Pretend this is a minus b, right? Pretend that's a minus b. The conjugate of that would be a plus b. So I'm going to write this expression, x plus 1 minus, oh my lord, okay. I didn't mean to do that at all, of course. Sorry. I'm going to go x plus 1 minus, e. Okay, let's try. X plus 1 minus 1 over x. But I'm going to actually rationalize. How do I rationalize? I use, sorry, what happened here? Okay, x plus 1. That doesn't change. Plus 1. Rationalizing. Ding, 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 ding. Put an arrow here where it's important. And you know how you could use notes on the quizzes and tests? So make sure you draw these arrows because they're going to indicate what you need to do. And you have to do that for both. Because you know how rational functions, you have to actually, oh my lord. We're back with this clean screen, okay? So remember, put an arrow here so you remind yourself, okay? We're rationalizing the entire we're trying to undo the radical, right? So we rationalize. You learned that in, when you were a baby too. So we're technically rationalizing, but we're rationalizing the numerator, which is a little bit of a unique thing, right? But we're just, our motivation is to get rid of the radical at the top, just as our goal used to be to get rid of it on the bottom, okay? So we can rationalize numerator or denominator, which I guess is a novelty for some of you, okay? All right, so we're gonna go limit. Okay, x goes to 0. And when I multiply these two things out, you should know, okay, I'm assuming that you know, it's going to be it's basically like a plus b times a minus b, which means only the outers remain, right? So you're left with x plus 1, which is the whole a, right? X plus 1, oh my gosh, minus 1, because the middle terms cancel out, right? This guy, and then this guy and this guy. The middle terms will cancel out because one is a plus and one is a minus. I don't need to explain that because you're a big boy now and big girl now. All right? So x plus 1 and then plus 1. Now you'll see that usually on the numerator or the bottom part or the top part when you're multiplying all this ugliness out, maybe you shouldn't multiply it out. That's a little trick that you'll figure out on your own. You'll become savvy enough later, okay? So now I see that I can simplify a little bit further. So I'm going to go limit x goes to 0, and this becomes x over x, right? Root x plus 1 plus 1. I see you see that, okay? And then you're like, okay, I'm trying to simplify all the way. So x goes to 0, 1 over root x plus 1. Remember, my motivation is to get all the way to a point where I can't simplify anymore, and I want to this, okay? So now wait, can I simplify anymore? No, I cannot simplify anymore. This is the farthest I can go, but I can now, I've arrived at a point in my equation or a problem where I can this. So now I put this. So I go equals 1 over, I plugged it in, right? 0 plus 1 plus 1. So I would get 1 over 2. Okay? Ta-da! So our limit of this function is 1 over 2 as it approaches 0. So go ahead and check that on your calculator too. But assuming all your calculation is correct, you probably did a good job, okay? Next thing I'm going to introduce to you is going to be these beautiful special limits that come up a lot. So that's on the next video. So make sure you watch it. But so far, so easy, right? And so fun, okay? All right.